Hello, my name is Adam. In this video, we are going to learn how to make the game Snake in Unity from start to finish. Snake is actually a game concept that originated in the 1970s arcade game Blockade. You maneuver around an object, picking up pieces of food which make the object larger. But every time you do so, it becomes harder and harder to avoid running into yourself. So in other words, you yourself are the primary obstacle you're trying to avoid. If you are new to Unity or even to game development, recreating older games is a really good way to start learning and growing your skills. For this project, all of the source code and assets will be made available to download through GitHub. There's a link in the description of the video. Let's go ahead and start learning. Let's jump in. Alright, the first thing we're going to want to do is create a new Unity project. So if you open the Unity Hub, we can create a new project using the new button in the top right corner. If you select the drop-down, you can actually choose which version of Unity you want to create. I'm going to use 2019.4 because it is considered the current long-term support version. For this project, it doesn't really matter though. We won't really be utilizing any new features that only exist in, let's say, 2020, for example. Let's go ahead and name this project Snake. Choose wherever you would like to save the project. And most importantly, let's select the 2D template here. This is going to be a 2D game. Let's make sure we set that because it will set up all your project settings accordingly. Go ahead and click Create. From here, it might actually take a couple minutes to initialize, so we'll have to wait for this to finish. Alright, now that our project is open, we want to start by setting up our scene before we begin scripting anything. Unity provides us a sample scene by default, so I'm actually going to rename this to Snake, and we'll reload. On the left is our hierarchy, where we can see any game objects that exist in this scene. By default, Unity provides us a camera game object, and on the right is our inspector, where we can inspect whatever object we have selected, and we can see the components that exist on that object. So, camera component, there's also an audio listener. For Snake, we're going to need a few different game objects, including a camera. We're going to need some walls. We're going to need the snake itself, and we're going to need a food object too. So since the camera's already here, let's just start with this. And all I want to do is change the color from this blue to a black. It actually doesn't matter, so feel free to set it to whatever you'd like. But I'm going to choose black, and you can see the camera preview down here. You can also select the game tab up here where you can preview your game in full. The other property I want to change on my camera is the size here, from 5 to about 15. If you see as I change this now, you can see this white outline is increasing or decreasing. So this is indicating the area that the camera can see. By setting it to 15, it's effectively making it so the camera is sort of more zoomed out, or in a sense further away from the origin. This is important because at the default size of 5, our objects are going to appear pretty large, and 15 is a little bit more appropriate for this game. But feel free to adjust that to your preference. So that's it for our camera. Next, we want to set up our snake object. So if we right click in our hierarchy, there's a couple options. We can choose Create Empty, which will create a brand new game object with no components on it except for a transform. Every game object has to have a transform, so that will always be there. The other option is to right click, and we can actually choose 2D object and sprite in this case. And this is going to create a new game object with also a sprite render, which is what we want for our snake. I want to reset the position of our snake here to 0, so I can actually just click the 3-dot menu and choose reset. It'll set all those back to its defaults. I'm going to call this snake. Let me switch over to my game view here. You can see that nothing is showing up yet, even though we have a sprite render. And that's because we need to actually choose which sprite to render. And so I need to first create one. In our bottom project panel here, I have my assets folder selected. I can right click, create sprites, and I can choose a square, for example. I'm going to just leave it named square. If I reselect my object, we can drag this into the sprite field there. You can also click the little circle It'll bring up a menu where you can select everything or search if you have lots of assets in your project. So now we can see it showing up, and I want to change the color from white to green. That looks good. Once again, feel free to choose whatever color you prefer. And we want to add a couple other game objects to this object. So one is called a rigid body, and then there's rigid body and rigid body 2D. The first one is intended for 3D games, but since this is a 2D game, we will select rigid body 2D. So a rigid body essentially turns this game object into a physics object. It tells this game object that it should be controlled through the physics engine. The reason we need this is to handle collisions. So when the snake collides into walls, when the snake, technically the snake will collide into food, which indicates that it's picking up that food. And also the snake can collide into itself, which would be a game over. So we need rigid body to detect collisions, but we actually don't want to simulate the motion of our snake through the physics engine. You can see there are properties like mass and drag and gravity. For this particular game, we don't want to do simulated motion. So we can actually change the body type from dynamic to kinematic. Notice how all of those properties go away. This will still allow us to control the movement of our snake through code manually while detecting collisions, which is what we most importantly need. And the last thing we want is a box collider. And in this case, the 2D version. Once again, the other one's intended for 3D games. Box collider 2D. What this does is actually just define the shape of your collision area on this object. The rigid body actually will detect collisions, but the collider defines the shape of the object. So in this case, it's a box just to match the shape. And we actually want to adjust one thing on this. So if I look at my snake object here, let me actually change the color real quick so you can see this. Notice this green outline on our object here. This is representing the collider. So if I disable this, it goes away. I re-enable it, it appears again. We actually want to change the size of our collider just slightly. I'm going to reduce this, for example, to be about half, so 0.5. And the reason for this is because at one point we're going to have multiple segments in our snake, right? They're going to be linked up together like this. And if all of these had a size of 1, well, then they would technically be colliding with each other. They're overlapping, and that's considered a collision. In the game of Snake, if you collide with yourself, you lose. So we don't want these colliders to overlap. So I'm just going to slightly decrease the size. You know what? I'll actually set this to 0.75 instead of 0.5. And you can see now, even though visually they're connected, the actual physical area defined by our collider is not, and therefore our snake wouldn't be considered colliding with itself. Well, let me delete these other ones. Let's go back here. So 0.75, that looks good. Oh, and we need to set one other property. We're going to set this to be a trigger. So a non-trigger object, if you have two game objects that weren't triggers, when they collide with each other, they're going to physically hit and like come to a stop, right? Like if you ran into a wall, you're gonna hit that wall and you're gonna come to a stop. You may even slightly bounce off of that wall depending on the physics properties. In this game, so that kind of stuff is really useful for a lot of games, but it also adds a little bit of complexity that we don't need for this game. In this game, for example, if you run into yourself, you're just immediately going to lose and the game's going to reset. We don't need to simulate the physics of you like hitting yourself and coming to a stop and all of that. And so by setting this to a trigger, it's just going to simplify some of our work later on once we start scripting everything. So everything will be a trigger. Oh, and I never set our color back to green. Let me change my snake back to green. But that will be it for our snake game object. Next, let's go ahead and create our food game object. It's pretty much going to look the same for the most part. So once again, we can right click in our hierarchy 2D object sprite. Let's reset the transform to 0. I'm going to make our food red. And we're going to use that same asset as the sprite. And now you can see it show up. And I can move this around and you can see our snake and our food. All we need here is a box collider. We don't need a rigid body. Only the snake is the only moving object in this game. So only the snake really needs the rigid body. Everything else still needs the collider to define the area, the collision area, but it doesn't need a rigid body. We're going to also set this to be a trigger. Every box collider we use in this game will just be set to a trigger for simplicity. And the size, I'll do the same thing for the size on this. I'll slightly change the size just to make sure that... so actually the reason for it on the food is... potentially snake is usually a grid. It sort of works in a grid, and if let's say you're moving our snake like this and you skim right past the side of our food, you're not technically eating it because you're not in the right column of it, and so we don't want that to be considered collision when they're side by side like this. So same thing, I'm going to change our food to be slightly smaller in its collider size. So in a situation like this, they aren't considered overlapping. Let's name this food. And that is it. So snake, food, that's that. And finally, the only other objects we need are walls. Technically, this is sort of optional, but I think it'll help in this case. So we're going to add some boundary walls to make sure our snake can't go beyond the limits of our camera here. So let's once again 2D object sprite. Let's call this wall. Let me just reset the transform. We'll use the same sprite as the others. I'm going to use a sort of grayish color here. We'll just make it gray. I don't want the walls necessarily to stand out too much. And let's position this. Let's start on the left side. So let's say -24. Make sure these are whole numbers. Make sure there's no decimals. And that's, once again, snake usually works in a grid-like pattern. And if we have floating point numbers like that, it's going to mess up our grid. So a whole number, -24. And let's increase its size here. We can change the scale on the y-axis. And let's make this about 25. Once again, whole numbers. Good, that looks good. We need a box collider on this as well. Mark it as a trigger. And finally, we actually don't need to change the size of this. We can keep it at 1:1. It perfectly lines up with our wall there, which is good. And cool. So that's one wall. Let's just duplicate this. So we can right click and select duplicate, or you can also press Control or Command D. And let's just flip this from negative to positive. Now we've got our right wall. Let's duplicate this again. This time we need it to be on the top, so we need to scale it in the other axis. So let's change the Y back to 1, but let's scale the X this time, and just until this lines up. So 48 looks good. Let's move it up. Make sure it lines up. Whole numbers, 12. And duplicate one more time and flip this to negative. And there we go. Now we've got our 4 walls sort of surrounding our area, which will prevent the snake from going beyond our camera. And actually, I'm going to make these slightly darker just so they don't stand out as much. So 20, that looks good. Okay, we'll call this wall. All right. And that actually completes our scene setup. We have all of our objects we need to begin scripting everything. All right, now we can begin to start scripting our game. We're going to focus on making our snake move as our first thing. So if we right click on our bottom project panel, we can select create, C# script, and let's call this script snake. Let's go ahead and select our snake game object, and we can drag this script onto our object here, just in this empty space. You'll see the script show up, and this means this script will now run as part of this game object. You can click the menu, edit script. You can also just double click the asset in the project panel, and we'll get a class that looks like this. By default, Unity creates us a class that always inherits from mono behavior, and they provide a couple functions that are just very commonly used. I actually like to just delete everything to begin with and just start fresh. And so, in order to make our snake move, we first need to declare a variable to keep track of our direction. So let's go ahead and do that. So let's call this private. It's going to be a vector2. A vector has two floating point values in the x and the y. And we need this because the snake can move both in the x-axis and in the y-axis. So we'll call this direction. And let's actually say it has a default of vector2.right. So by default, the snake's going to move to the right. From here, we can add a function called update, which Unity is going to call automatically for us every single frame the game is running, or every single frame that this script is active on a game object. And this is commonly where you'll handle things such as input. And so that's what we need to do. We need to assign our direction based on the input the user presses. So we can say if input.get key down. I can type get key down, and then we can specify the key code. So any key you want. I'm going to use W, A, S, and D for my controls. So I'll start with W. We'll say direction equals vector2.up if you press W. Basically gonna do the same thing. So else if you press S, well then we'll move down. Else if you press A, you'll move left. And else if you press if you press D, you will move right. And there we go. Now we're assigning our direction based on our input. We haven't actually made our snake move yet, so that's what we need to do next. Based on our direction, we actually need to change the position of our snake. Now we're actually going to handle that in a different function called fixed update. The difference between these two is that update is called every single frame your game is running, but your frame rate is variable. It just depends on how well the game's running for your computer. Whereas fixed update is always ran at a fixed time interval. And this is important for physics related code, because if your physics was simulated with a variable frame rate, well then you're going to get some very undesired and expected inconsistent results. So usually all physics is handled in fixed update. If you remember when we set up our scene, we added a rigid body to our snake to indicate that this is a physics object. And so that's where that's why we're going to handle all the movement in fixed update. So based on our direction, we can actually move our snake. So we can say this.transform, which is accessing the transform object here. And we can change our position. So position, and we're going to say equals new vector3. Our position here is always a vector3, even though this is a 2D game. And we can provide our X, our Y, and our Z. And so we're going to take our current position in the X and add it to our direction in the X. And then same thing in the Y. Position.Y plus direction Y. So our current X plus whatever direction we're going in the X plus our current Y with the direction. And our Z can just be set to 0 because we don't need that for this game. Now the reason I set it up this way is because we actually need to do one more thing. We need to actually round these numbers here to make sure our snake is sort of aligned to a grid. And so I'm going to wrap this statement here in mathf.round. And then same thing with our Y, mathf.round, mathf.round. And this will make sure all of our numbers are always whole values, which when we did our scene setup, I explained how we want our snake to always be aligned to a grid. And so we need whole values to do that. Let's go ahead and test this out now. Our snake is on there, so we can click our play button. And you can see our snake is moving now. And I'm using my controls to change the direction. Now I can go beyond the bounds because we haven't detected the collision yet. Nothing happens when I eat the food. That's all expected. Now, one problem is we're moving way too quickly. And that's because our fixed interval here is too often. So we can actually configure that in our project settings. We go to edit, project settings. We go to window here. I'm going to bring this up here. And we go ahead and select time. We can change this fixed time step, which is how often that fixed up even says here. Frame rate independent interval that dictates when physics calculations and fixed update events are performed. So let's set that to 0.04, and that's much more appropriate. That feels a lot better. It's not too fast. We can even change this to something else if we want it to be even slower. And notice how I'm I'm kind of snapping to each grid position in a sense. I'll always be able to like perfectly line up with this food object. And that's because of that rounding we're doing. Play around with this fixed time step until you find a setting that works for you. It's basically one way you can change the difficulty of the game. If you want your game to be really difficult, then make it really fast. But I think the 0.4 felt good for me. So that actually finishes our snake movement. Next, let's go ahead and start scripting our food object so we can randomize the position when the game starts, as well as every time the snake eats it. So in our project panel on the bottom, let's right click, create C# script, and we'll name this one food. And let's add this script to our food game object this time. So we'll drag it into the empty space, just like we did for the snake. Let's go ahead and start editing this. I'm gonna clear everything out just to start fresh. So for our food, we need to randomize the position. But to do that, we're gonna need to know where the food can be positioned. We wanna make sure it never randomizes outside of our bounds here. It should always be inside the bounds. And so one way we can do this is we can actually create another game object, create empty, we reset its transform back to 0. That's actually pretty important for this one. And let's go ahead and add another box collider 2D. We'll mark this as a trigger because we don't want anything to actually collide with this. It's going to be sort of an invisible bounds. I'm going to name this grid area. We switch over to our scene view so we can visualize the size here. And what I want to do is line up the size of this with our boundary. And I'm not going to actually line it up exactly with the walls themselves. I'm going to make it always half a unit away from the walls. And this is because, let's say, for example, our food randomly positioned right here on this point in our grid. The very corner. If we move our snake, move our food down to that corner, so roughly there. Notice how now our food perfectly lines up with the walls, right? And that's because all of our game objects, the center point is our sort of 0, 0 for this object. It's always based on the center. And so if we lined up our grid all the way to the edge, well, then our food could potentially spawn partly in the wall, which is not what we want. And so we go ahead and we mark our grid area half a unit away on all sides. Okay, now that we have our grid area bounds, we can create a reference to this in our food script. Let's go ahead and open that back up. We're going to create a public variable here. It needs to be public so it show up in the editor. And we're going to type it as the same type of our component that we just added, which is a box collider 2D. And we're going to call this grid area. Now look at what happens in the editor. If we select our food game object and we have our script here, notice how this property now shows up. And we can actually drag in our reference to a box collider 2D in this field. So I can drag in my grid area over here, and boom, now we've created a reference to that, to this box collider in our food script. The box collider contains a property called bounds, which gives us like the exact size and everything. And that's what we'll use to generate random numbers. So let's go ahead and create a function called randomize position. And let me get a reference to those bounds I was just referring to. So we can say this.gridArea.bounds. Bounds. Now we can get a random number within these bounds in both the X and Y axis. We're going to use Unity's class called random, which is just a class for generating random numbers. And there's a function called range, which allows us to generate a random number between two points. So range, and we can actually say bounds.min.x and bounds.max.x. And same thing in our y-axis. Random range, bounds.min.y, bounds.max.y. And there we go. Now we've generated a random point within this bounds that we have defined in our editor. All we have to do now is assign our food's position to be these coordinates. This.transform.position equals new vector 3, x, y, and z doesn't matter, so we'll set that to 0. And one more thing is we need to round these values, just like we did in our snake script. We need to round these to ensure that everything aligns to the grid. Our range here returns a floating point number, and so we need to make sure everything is whole numbers. So I'll round these as well, round x and round y, and there we go. Let's go ahead. Oh, we actually need to call this function first. And so we're going to use a built-in function that Unity calls automatically on any mono behavior, which is called start. Start is going to be called the very first frame this script is enabled on a game object. And so on start, we'll just go ahead and randomize position. Let's go ahead and test this. We'll run our game. Notice our food's in the bottom left. Let's run it again. Top right. Let's run it a couple more times. Yep. Yeah, so you can see every time it's in a random position, which is perfect. And notice how I'm perfectly sort of aligned with this object, right? It's not, I'm either directly adjacent to it or I'm directly overlapping it. And that's because of the rounding we're doing here. So that's very important. All right, the next thing we want to do is actually re-randomize the position every time the snake eats the food. So we need to detect when the snake collides with the food. We set up our colliders on all of our game objects already, and we marked them as triggers. And so what this component is going to do is it's going to provide us with a function called on trigger enter 2D. It's the 2D version. There's one parameter here, which is another collider 2D, and we'll call that other. So essentially this function is going to get called automatically whenever our game objects collide with one another, or in this case when the trigger is whenever it's triggered. And then there's like enter and exit, but in this case we just want enter, and it gives us a reference to the other object that collided with this one. So in here is where we can call randomized position. Now, one thing we should do, however, is check what other game object actually collided with the food here. In this game, the only thing that could collide with it is the snake, but it's generally a good practice to check that this other game object is what you expect it to be. So one way we can do that is using Unity's tagging system. So we can say if other.tag equals, then let's say player in this case, then we will call our randomized position function. So let me show you how that works. So on any game object, you can see this tag up here, and you can select different tags. You can add your own tags. There's a few default ones that Unity provides, such as player. And so we want to go to our snake game object, and we want to tag our snake as being the player. So this means now when our snake collides with our food, this function will be called. The other collider will be a reference to our snake, and we'll verify that that is indeed our snake by checking the tag is the player. And if that's the case, we'll go ahead and re-randomize our position. Let's go ahead and test this out. Here we go, boom. Randomizes every time I collide with that object, which is perfect. Now it comes across as if I'm eating the food, and then a new one is spawning. Awesome. So that actually completes our food placement and randomization. All right, now that we've got our food game object scripted as well as our snake, we need to sort of combine some of the functionality to make it so when you eat the food, it will grow the snake in size and you'll have more segments being added. We don't need to create any new scripts for this. We're just going to expand upon our existing snake script. Let's go ahead and open that up. The first thing we're going to want to do is create a list to keep track of all the segments of our snake. Let's go ahead and do that. Actually, I need to import using system collections.generic so I can define a list here. And this is just going to be a list of transforms, and I'll just call this segments. In our start function, we can go ahead and initialize this list, and we can add our very first segment, which is just sort of the head of the snake, which is the object that this current script is attached to. So this dot transform. And then we're going to need to continue to add to this list here. Now to do that, we're going to have to create a brand new game object programmatically that sort of matches our existing snake. And so what we can do is use something in Unity called prefabs. So let me explain how this works. Here we have our snake, and I'm going to just duplicate this. I'm going to first call this, or I'm going to call this snake segment. And all we need on our snake segment is the renderer and our collider. We don't actually need the rigid body, and we don't need the script itself. The script will only exist on our main head object. Same thing with the rigid body. Only the head object sort of controls the movement of our snake, so only that object needs the rigid body. Our other snake segment does not. And what we can do is actually drag this object directly into our project panel at the bottom. It's going to turn this game object into an asset that we can then reuse over and over again. So this is referred to as a prefab. You can even see the file name is called snakesegment.prefab. I can actually delete this from our scene. We still have it here as an asset. And for example, if I were to, I could just create a bunch of these in our scene, and now I just have copies of them, right? It's just a way of me of sort of cloning a object over and over again. And let me actually reset the transform here. Okay, good. That all looks good. And now we can reference this prefab in our script. So let's go ahead and create a reference to our prefab here. The type is often just a game object, but in this case, since our segments list is a list of transforms, I'm going to type this as the same as that, and we'll call this segment prefab. Let's take a look at what this does in our editor. So creates a new property here, and then we can create a reference to this object. And so we can take our prefab and drag it in there. And now we have a reference to our prefab in our script here. Now let's go ahead and add a function called grow. And what this is going to do is it's going to instantiate a copy of this prefab. So we can do that by saying instantiate and then passing in the object you want to clone. So this dot snake or this dot segment prefab. Awesome. And then let's keep a reference to this new segment. And then we can add it to our list. The other thing we need to do though is set the position of this segment to be at the end of our snake object. So it should be, we're going to add them always to the tail. And so what we can do is say segment dot transform, or well, it already is a transform, so I don't need to say that, but I can say segment dot position equals, and then I can grab the very last element in our current from our current list of segments. Segments.count -1 will get us the very last one, and I can just set the position of this new segment to match our tail object. Awesome. Now we need to call our grow function somewhere, and this is going to basically be the same thing as our code from our food script. So I'll actually go ahead and just copy that. And in this case, other.tag is not player, but it's going to be food instead. And then we'll call our grow function. Now, I haven't established that tag yet, so let's go ahead and go to our food game object, and we need to mark this as being food. Now, that's a custom tag, so I can add a new one. I can click the plus button there, and we'll call this one food. And save that, go back, and now I can tag this as food, which will satisfy this condition here. And then we'll call grow. Awesome. Now, let's actually, we'll go ahead and test out. This isn't fully working yet, but let's go ahead and just test out what happens here. So notice how I now have more of these segments. You can see in the left hierarchy, more and more of the segments are being cloned. They're not positioned correctly and they're not moving with the rest of the snake. And so that's what we will do next. But they're at least spawning there. So what we need to do is make sure all of these segments follow along with the rest of the snake. And so we're going to do that in the same place where we move the rest of our snake, which is in fixed update. And the important thing here is we need to move everything in reverse order. We need to move everything from the very tail to the head first. And I'll explain why in a minute. But we need to loop through our segments. So I just said we have to, we need to change the position of them in reverse order. So I actually need to loop backwards here. So this needs to be start at the end. And it needs to go until it reaches 0. And instead of plus plus, it'll be minus minus. And we can say segments I dot position equals segments I minus 1 dot position. And so let me show you what this is doing. It's easier to visualize it in our editor here. So we have our snake. And let's say there's a couple segments here. Okay. We're changing the position in reverse order. So we're going to go with this tail one first. And the tail one is going to assign its position to be the one in front of it. So it's going to move to here. And then we'll go to this one, and this one's going to move to here. And we'll go to this one, and this one will move to here. And then finally, our head game object will execute this code to move its position there. So this makes sure that sort of each segment is following the one in front of it. And the only way to do that correctly is if we iterate in reverse order and make sure we update the head last. Let's go ahead and retest this out now. Here we go, look at that. So you can see the snake is getting bigger, everything's following along appropriately, and it's working nicely. Now, one thing I might want to do is visually distinguish each of the segments in the snake. So we can actually go ahead, let's go to our snake object here. Well, actually, no, let's go to our snake segment prefab that we created, and I can change the scale of this object just slightly. So let's say 0.75 and 0.75. And now let's see what happens. Yep. So notice how there's sort of some extra spacing in between each segment, which just maybe helps to visually indicate the different segments. I think it just overall looks a little bit better that way. I think I'm going to actually increase this a little bit, maybe to 0.9. And then I think that might look a little bit better. I just want a little bit of gap in between each segment so you can start to distinguish them. Yeah, that feels pretty good. All right, there we go. So that actually completes our snake growth, which is sort of the kind of the most important aspect of the game. And all we have left to do now is to handle collision on the boundaries, as well as when you collide into yourself. All right, we're nearly complete with our game. We just need to do the final collision detection. Let's go ahead and open up our snake script. Once again, we're just going to expand upon this. And we already have our function here on trigger enter, which we use to detect collisions. So if we add another if statement here, so instead of detecting when we collide with food. Let's say that when you collide with maybe an obstacle, well, then we will reset the state of our game. So let's call a function called reset state. Let me add that here. And let's go ahead and tag our game objects with this obstacle, with obstacle tag. So first I need to add a new tag, obstacle, and this really just looks the exact same as what we did for our food. So obstacle. I'm going to go ahead and select all 4 of my walls, so I'm going to tag those as obstacles. And I'm also going to tag my snake segment prefab as being an obstacle too, because that's the whole premise of the snake game, where if you run into yourself, you lose. And so you yourself are the primary obstacle you're trying to avoid. So we're going to mark the snake segment as obstacle, but we need to make sure we leave our main snake head object as the player, because if you remember on our food script, we check to see that if the player collides with the food, well, then it will eat it. So only the snake head object will do that. All right, so back to our code. We check if we're colliding with an obstacle. If we do, we will reset the state of the game. So what are all the things we need to do when the game resets? Well, we need to clear out our list of segments and start over again. So we can iterate over this. And we actually want to start at index 1 instead of 0. And that's because index 0 is our main snake head object, which we don't want to delete. And in fact, that's the object that this script is attached to. So we definitely don't want to delete that one. So we'll start at 1 here. And we'll say segments.count, I++. And we can go ahead and call a function called destroy. And we can pass in a reference to a game object we want to destroy. It needs a game object reference, not like a transform. Our list here is a list of transforms, so we can say transform.gameObject to get the appropriate reference there. Then we can clear our list, and we actually need to make sure we add back our main head object. We didn't delete this one, so we need to add that back, but we do need to clear the list because even though we're destroying these objects, there's still technically a reference to them. And then finally, what we need to do is reset the position of our snake back to the start. So we'll just say position equals 0. And let's go ahead and test that out. Play our game. Oops. Play. Eat a piece of food. There we go. We're growing. Let's run into a wall. There we go. All the segments disappear. My character resets. Let's test all 4 walls. Yep, so on all 4 walls, I was able to, it reset me. Let me test if I run into myself. I need to make our snake a little bit larger first. Oh, I screwed that one. I just completely lost on my own faults. All right, so let's get a little bit bigger. Okay, let's get one more. We'll do one more. Okay, that should be big enough. There we go. So I ran into myself and it reset. So everything is working correctly. That looks good. Nice. Now, one thing I don't like is how when you start the game, you are a size of just 1. It doesn't really feel right to me. So I think I want to make it so the snake has an initial size. We can go ahead and declare a variable for this called initial size. Maybe it has a default value of 4. I'm making this public so I can tweak it in the editor. I will be able to change this value in the editor in case I want to have a different size. And then like when you reset the state of the game, we will actually just want to add back however many segments until you've hit that initial size. So we can say for int I equals 0. Well, actually we'll start at 1 again because we've already added our head. And so I is less than our initial size, I++, and we'll go ahead and say segments.add, and we'll instantiate our prefab just like we did up here. All right, let's see if that works correctly. If you look in our script here, you can see the initial size is 4. Nope, that did not work correctly. Oh, and that's because So it'll work correctly when you lose. So there, I lost, and then our size gets reset. But on the very start of the game, this gets called, but we aren't executing that code. So I'm actually going to change this to just call reset state whenever your game starts. Now there's this one problem this will cause, and that's because in this function we are accessing our list here, but our list has not yet been instantiated, and so it'll actually cause a crashing error. And so let's just go ahead and initialize this right away to make sure we don't run into that problem. Let's try testing this one more time. Yep, so there we go. We have an initial size of 4. I can still continue growing. If I lose, it resets. Let's say, for example, I change this to 8. Play again. And there we go. Now we have an initial size of 8. And so that feels a lot better. It feels a little bit more natural. Awesome. So that actually completes a sort of core working game of Snake. This was just a pretty simple implementation of the game Snake, but I hope you learned a thing or two in the process. I would actually challenge you to see how you can continue expanding upon this foundation we have built here. What else can you add? Is there any new features or functionality you can add? Any new game mechanics? One thing we didn't really do at all in this project was any UI stuff. We didn't really add like a start menu or a game over menu. So maybe that's one way you can continue expanding upon this. All of the project files and source code for this game are available to download for free in GitHub. There's a link in the description of the video. I've gone ahead and cleaned up some of the code and added some additional comments that you can learn from. I appreciate you spending the time with me to learn how to make the game Snake in Unity. If you feel like you've learned something, then go ahead and give this video a thumbs up. And if you would like to watch more videos very similar to this one, then go ahead and subscribe. Feel free to leave a suggestion in the comment as to what other games you might want to recreate that we can all learn from. Thank you.